All right, so 32.
Yeah.
So there's two different ways you could do this, right? So anytime you're given a problem like this, what you need to think about is kind of like, what do I know from this problem? In other words, what variables do I know? Um, Dang, I can't write on the screen, can I? No. All right, so let me try this. It might be ugly, but at least it'll be this. So this gives you something, right, from rest. Falls a distance h during the first second of time. All right, so we know it's free fall. So this would be my v naught. This is my initial, right? Ah, this is my h. I know t equals. All right, this is not working. All right, t equals 1, right? So if I look at it, what I could do is just kind of I could just plug numbers in. Like in other words, find what H would equal in real life, right? I know V naught, I know G, or no, I don't know, I know the acceleration, right? I know acceleration, I know time. I could find delta Y, right? How far it went down. And then what I could do is I could say, okay, do another problem where I know it's V naught, but now it's going to go for 2 seconds and then find that difference. Did that make sense? Who asked me this? Was it
Yeah,
Faithy?
yeah, it was me.
All right. Did that make sense to you?
Nah, I just didn't get the second part, to be honest.
Okay, so you go with the first part, like just solve for 1 second, right? Solve for
Mhm.
delta y for 1 second. So you get whatever it would be. You get a number for delta y for 1 second,
Yeah.
right?
Wait. Yeah. I
Like,
understand it. I just the second part really like caught me off guard because I didn't
okay.
expect. Yeah.
So the second part, right? If we want to know how far it goes in the second second, so in other words, from second 2 to 3, right?
Mhm.
What I'm going to do is I'm going to go from the start because I know something there, right? I know its initial velocity is 0 at this point where I'm dropping it, right? So what I'll do is I'll set V naught is 0, same thing. I'll set acceleration is still negative 9.8, right? And then what I'll do is I'll say instead of going to 1 second, I'm going to go 2 seconds. All right. So that gives you from 0 to two, right? And then what I'm going to do is take the first delta y, that was the first second, and subtract it from the total delta y, and then that's how much it went the second second. Does that make sense?
Yeah, that makes sense.
Okay. So you could do it that way, or you could just compare variables. I would have to be able to write on the screen to compare variables, and I don't have this screen's not touchscreen, so that's a little bit more convoluted. But did that aspect make sense? Like you can always calculate it, right? And say, okay, well, how many more times is it? And you'll find it's 4 times as much.
Okay. Yeah, I got
Okay.
you.
Any other ones you have want me to talk about?
Um, Not particularly.
Okay. Anybody else have any other multiple choice they want me to go over? We'll
Can you
start.
do some of the ones from the NIMSY packet? Because we never like got like to ask questions about the multiple choice from that one.
Yeah. I'll pull it up. Let's see. Let me find it here. That's not it. Kinematics. All right, let me share my screen here. All right, can you guys see it?
Yeah.
All right, let's see here. Austin, do you have any in particular you want me to do, or you just want to kind of look at them first?
Can you do 16?
16. Okay, yeah, so this is a good one to do. I'm telling you, like 70% of the exam is like reading these graphs because we did a lot of these graphs in the multiple choice. So the first thing when you're looking at these graphs is look at what type of graph it is. Let me bring my pen back up, even though I can't write. All right. This is a velocity versus time graph. Okay. So knowing that, all right, knowing that, all right, you have to think what are the graph characteristics that I can get from a velocity versus time graph, right? So from a velocity graph, I know that the slope is equal to acceleration, and I know the area under the curve is equal to the displacement. So then I look and I see that they're all displacement versus time graphs in the answer. Does that make sense?
Yeah.
So what I look at is let's look at each section. Conceptually, what you should know is that during that time period, you're going to start from rest, and then I'm going to keep going faster at a constant acceleration, right? This is a constant slope, so the acceleration is constant. So you're going to keep increasing your velocity. Does that make sense? So from there, anytime you have acceleration, you should know on a graph, on a displacement versus time graph, it has to be curved. It's either going to curve up or it's going to curve down. Okay. And the thing you have to remember is if it's a positive acceleration, it's going to be a smile. All right. If it is a negative acceleration, it's going to be a frown. So I look here. What's the slope of the velocity versus time graph? Well, it's positive, right? In the first section, it's positive. So I know it has to be a smile. So really, the only ones that could possibly be it right now are B and D. Do you understand? Everybody good with the thought process so far? Like that makes sense?
Yeah.
All right. Then I look at the second section and I know, okay, if it's a if it's a flat part on a velocity versus time graph, that means he's going at a constant velocity. So the velocity remains the same. So now what I have to think about is this. Is he still moving? Yeah, he's moving. He's just at a constant rate, right? So what I know is on a displacement versus time graph, it should be a straight increase. He's still moving away. So if I look at this, if I look at what B is saying, this is a possible answer for the first section. But what this means on a displacement versus time graph is he's standing still. So can it be B? It can't, right? Because he's definitely moving. He has velocity here. Well, excuse me, if I look here, it's curved in the beginning, which we need because it has positive acceleration. Then I go from here to here, and that's a straight line, right? Constant velocity, your displacement will increase at a constant rate. Then I look at the end. What's my slope here? Positive or negative? What's negative, right? It's going down. So it means I have a negative acceleration. So on a displacement versus time graph, I need a frown. Well, this is half of a frown. So does everybody understand why it's D? Did you, I mean, I just wanted to walk you through all of the parts there. Everybody good?
Thank you.
Any other ones off the NIMSY? This one, did you guys good on this one?
Can you do that one too?
Yeah.
18.
Yeah. So again, first thing I need to look at is what type of graph is it, velocity versus time, and then think about what graph am I going to? I'm going to displacement versus time. So that's going to shift your thought process, okay? So what do you notice at the start? A flat part of the graph. A flat part of the graph means a constant velocity, right? So if I'm moving at a constant velocity, I should know that I'm going to increase at a constant rate my displacement. So right away, I mean, the only ones that are valid right now with this first section, just looking at it's moving at a constant speed, the only ones that are valid would be A and D. Does that make sense to everybody how I eliminated B and C, right? By process of elimination, they're not increasing at a constant rate. So then I look, I have a negative slope, agree, right? So that means I have negative acceleration. So what I need is a frown. All right. Well, if I look here, I have a frown on A, right? The top of A is a frown. I got a kind of frown there, but I'm not moving during this time period. So if you look at the dashes during this time period, I'm I'm not decreasing at a negative rate, right? And I'm still, if you think about it, I'm still moving forward. How do we tell displacement from a velocity versus time graph? Well, it's the area. If I look at this area here, right? Oh, hold on, me. If I look at this area right here, it's this. Would you agree it's the same as this area? Does that make sense to everybody? So if I asked you, where am I at this time here? Your answer should be, well, you're back to the starting point, right? Because if I add this area to this area, it equals 0. So I need to be back at the starting point at the end. But I never went negative. That's how you know this is not right. That's not right because you never went negative. You have positive area and you start taking away the positive area from this, right? And then at the end, it gets to 0. So this is why it is A. Any questions about that?
Wait,
Uh,
why would
but
it never be 0? Why did it never like go negative?
it never goes negative, right? Because think, displacement is the area. So when I get to this point here, I have positive area. Agree? If I look here, if I look at what I'm doing here, would you agree that this area below is not as big as this area below, if above, right? Right here, if I just stop at this time, this area here is bigger than that. Yes. So I still have positive area, which means I have positive displacement. I haven't gone backwards yet. Even if I got to the point right before the end of the graph, this area below is still less than that area above. So, in other words, I'm still positive displacement. As long as the area is positive, you still have positive displacement. The only time it goes to 0 is when you're at the end of the time. Dude, this sucks. I wish I had a touchscreen thing so I could just draw on it. Um, when you get to the end, the area is equal. So, in other words, you're back at the starting point. So, you're back at 0. But at no point have you had negative displacement. Yes, you were going backward. You were walking backwards towards the start because you had negative velocity, but you never got negative displacement. Does that make sense?
Yes, thank you.
Okay. Um, I'll keep scrolling down. See if you see one you want me to do, just yell. Oh, never mind. This is free response. We were at the end. Okay, so let me stop sharing this. Um, let me share this. Where'd it go? Oh, sorry. Hold on. Hold on. All right, do you see the review sheet? Just want to talk you through it right now. So multiple choice. The only way to study for physics multiple choice is just do. Make sure what I would do before I just try the multiple choice. Make sure you're comfortable with all of the information about one-dimensional motion in the NIMSY packet. All right, you have to be good on what you can get from each graph, right? Isn't that all? Like all the multiple choice we've done, I've just talked about what we can get from each type of graph, right? I said, what do we know from this graph? What do we know from this graph? How do you relate it to this graph, right? So make sure you're good to go on those. All right. Then once you are good with the NIMS, I don't mean like memorize it word for word. I just need you to read it and be like, yeah, I got that. It makes sense to me. I understand that, right? You don't have to memorize stuff, right? You just got to be able to like get the concepts. You see the concepts, like I'm applying it and through my thought process when I'm solving these. All right. So just practice multiple choice. That's all you can do. There's like 80 questions I posted. I mean, the only way you can do it is the only way to get better is just practice. Okay. So the exam's three parts. I know you guys probably watched this video, but I can talk through it a little bit more and you guys can ask questions about it. So again, you guys are lucky. This is literally the easiest test I've ever seen in my life. Like my regular physics classes last year had a harder test. I'm not super thrilled about it. All right, so it says, all right, let's just go through this as like a checklist if it makes sense to you. So given data, you'll be given data, and all you have to do is draw the best fit line on there. I know we did it on a computer, right? We did it for the lab, the Father Brown lab. You drew a line of best fit with your computer. All you're gonna have to do here is with a ruler draw it. So basically, the how you do that is you want to get the line that's as close to every point as possible and just draw a straight line. That's it. Did anybody have any issues with that or questions or concerns about that part?
The points aren't going to be like a scatter plot, right? They're going to be like in a straight line for us to easily draw a line of best fit so we can
Well,
find.
it's not going to be a straight line where you're just drawing through the line. Does that make sense? Like it'll be a scatter plot with a linear uh relationship, right?
Okay.
It's not
Yeah.
going to be like point and just trace lines. Like
Yeah.
I don't want to know if you can connect the dots, right? All right. Then it's calculate the slope. I mean, that should be easy. Everybody should be good with that. My only recommendation is after you draw that line, make sure you pick 2 points that are like pretty far apart and that are like line up, that kind of go through. So it's very easy to pick, right? And you're just doing your basic slope equation, rise over run. That's literally it. Um, then you need to write an equation for the line. In other words, y equals mx plus b. So literally just plug the slope in for m and see where b is, right? See where the vertical intercept is. Do you have any questions about those two parts? Finding the slope and then equation for the line. Good. Okay. So the next part is really easy. So you're going to get like a point on a graph, and it's going to give you the uncertainty of this measurement. So, whatever it is, plus or minus, whatever, is going to ask you to draw the error bars on that point. So basically, you just go up or down how much the uncertainty is, right? I know we didn't physically draw error bars yet, but you had the lecture that described the error bars. So basically, if I was drawing this, you're going to get a graph, right? Choom, choom. There's a point here. Sorry, next time I'm gonna get on my iPad and do this. This sucks on my computer. I just don't know if I have Fairfax. I can't get on Fairfax Zoom. All right. So what you do is whatever the error is, you go up that much. So say the error was 1. I would go up 1, draw a line, and I would go down 1, draw a line. Basically, all an error bar does is show the range of accepted values that that thing could be. Is everybody good with that? Any questions? I mean, dude, it's pretty easy. And then the last part is you'll have to do something like this. Where is it at? I think it's right here. Everybody see this? This is the uncertainty key. You literally have to do something like number 8. You're going to do a basic, so you're going to be given two variables. In this case, it's ooh, area, maybe? Yeah, it's area and force. This is force and area. And you'll have to calculate. It'll give you an equation. It'll say, all right, calculate this. So right away, we need what you're trying to get is the value plus or minus the change in the value, right? To do the value, you just take the actual values and do the operation. In this case, the equation asked you to divide. So I did 3.6 divided by 0.05 and got 72. I did sig figs here. The bottom one has one sig fig, so I could only go to one sig fig. That's why that's 70. So that's your P in this case. So that's your unit, uh, your basic your number, right? Is everybody tracking with me? And then you get this equation on your equation sheet, and it's the error equals the number, right? So I would plug 70 back in there over the error divided by the number plus the error divided by the number, right? So does everybody see what I did there? I plugged zero point 0.1 because that's the error right there, or 0.01. The number was 0.05, did the division. I did zero point 0.1 goes here because that's the delta, the change in, and I did 3.6, bang, just add. When I look at this, it's one sig fig, one sig fig. So that's where I get that one sig fig, and bang, there's my answer. Again, remember, you have this equation on your equation sheet. You're going to have your equation sheet. I made a special copy. You're going to get it, before the exam. Any questions on this?
For the error bars part, like graphing the error bars, are we going to be given the error for that, or are we
Yeah,
going
yeah, yeah,
to?
yeah, yeah, absolutely. You'll be given something like this. Say you get 3.6 plus or minus zero point 0.1. So the point's already there. The point will be at 3.6 on the graph, right? So the point will be at 3.6. What you have to do is basically go up zero point 0.1, draw it, and go down zero point 0.1, draw it. Did that make sense? Is that good?
Yeah, thanks.
Okay, yeah, perfect. Any questions? Any more questions on this uncertainty error bar stuff before I move on to the last section? Nope. Okay. Dude, trust me, I would have rather been in school today. I just stood out in the rain for 8 hours. Literally 8 hours in the rain, soaking wet. It was miserable. It's terrible. All right, let me get back to this. All right, so we hit all these. So normally I would expect to have a lot of word problems here. I think there was only one word problem, which blows my mind. Um, So let's walk through this. So the first two go back to graphing, right? This is where you have to make that connection from the three variables, right? Displacement, velocity, acceleration. You're going to be given a graph. So you have to be given one of them. uh what's it say? You're given a velocity graph. You need to draw a displacement and acceleration graph. And then the next one is given a displacement graph, draw acceleration and velocity. So that's why it's so important to understand what you can get from each graph because it's going to help you piece it together, like piece everything together. Does that make sense? Does everybody understand what I'm asking you to do there? Okay. Um, you have to solve word problems. So I think this one is like it's pretty basic. I'm trying to think. Do I have the test on me? Let me look at it real quick. Obviously, I didn't write this test. Okay. So, do you guys still see do you guys still see the list? I clicked a bunch of things. I don't know what's happening. Did you guys still see it?
Yeah, I can see it.
Okay. All right. Sorry. All right. So, what I recommend doing is making sure you look at what's it called? Motion and one-dimensional worksheet. Remember one of the first worksheets we did in this chapter? I did the problem for you. Let me pull it up real quick. Number 9 on that. I would look at that. Um, let me share that. You guys remember doing this? I did the airplane one first, right? I did this one first, the airport one, and I was like, "Hey, you guys know GoldenEye?" And nobody knew it because you guys watch stupid movies. You guys remember that? All right, cool.
Yeah.
Uh, then I did this one, where the thing about hitting the car, hitting the kid or whatever, running out in the road. I would make sure I know how to do number 9. Good, great. No, I'm not doing it because I did it for you in class. After that, the key to that is remembering that the equations only hold true for constant acceleration. So if I think about that problem, I was driving in a car at a constant speed. If I'm at a constant speed, what's my acceleration? Anybody on the call? Nobody knows that? If you're driving at a constant speed, what's your acceleration? Are you guys messing with me right now? It's 0, right? Everybody knew that. Okay. Yes, it's 0. Then if I hit the brakes, I'm changing my velocity, so I have some sort of acceleration. So what you have to do is you got to break that up. You got to break it up in first part when it's non-accelerating, and then the second part when it is accelerating. Make sense? Good. You gotta be able to graph data. Literally, just put data on a graph. Like, okay, this is this and that. Put it on the graph. Uh, Calculate speed, velocity, distance, displacement for graphs. I would review my PowerPoint. We did that. Agree. We did that as we were lecturing. Remember my lecture when I was walking back and forth, asking you guys questions? I would definitely know the definition of, well, not the definition, but like the difference. What's the difference between distance, displacement, velocity, and speed? There are differences. I would definitely be talking about vectors and scalars, stuff like that. And that's it. I mean, honestly, it is the easiest test I've ever seen. Somebody asked a question in the chat. 0. Oh, yes. Good. You answered it. Thank goodness. Enoch, thanks. I was getting really worried that you guys were like, oh, yeah, I have no idea if you're moving at a constant speed, what's the acceleration? That would be a bad look. So now I mean, I just went through the whole test. So I'll just open it up if you have any questions in general. If you need me to do problems, if you need me to just answer questions. If not, yeah, I mean, if you have more questions, you can come see me during Raise tomorrow or whatever. So, anybody?
How many questions is the test?
What the hell kind of question is that?
I'm just trying to like see if it's long.
It's 3 parts. Dude, it's easy. Where's it at? Hold on, I gotta find it. So part 1, um, so there are 15 multiple choice, and part 2 is 7 questions, And then part three is 4 questions, but there's a lot of like different like A, B, C, but it's like pretty, dude, it's so easy. I'll give you this test and then I'll show you what I gave last year. And you'll be like, good looks, Robinson. Any questions? Any other questions? Now's the time. You got me. All right. If nobody else has any questions, then I'm not going to sit and hang out on Zoom because I'm toast from hanging out outside all day. Um, yeah, if you think of something, sign up for a raise tomorrow. And if I'm full or I don't approve a pass or something, just have your teacher make a pass to me because I don't care. I don't care. I don't even know what buttons to hit when I'm in EA Hall Pass. So, all right. Everybody good? If that's it, that's all I got.
Thank you.
Yeah, we'll see you guys
Thank
tomorrow.
you.